In this video we're going to practice using the derivative to analyze a function, and we're going to just look at this a little bit harder function. So the first thing, we're going to find the critical point. So we need the derivative. Okay. Hopefully you look at this and say it looks like a product. So we're going to have first multiplied by derivative of the second plus the second multiplied by derivative of the first. Okay, I could clean this up a little bit at 4x squared e to the 2x plus 4x e to the 2x. Now, knowing I'm going to need the critical points, I think it's probably really helpful to do some factoring here. So I look and I think, well, I can take an e to the 2x out of each, I could take a 4 out of each, I could take an x out of each. So let me do that. Okay, I'm going to have 4x e to the 2x and then x plus 1. And this is the derivative that I'm going to analyze. Certainly any step up there I could use, but I think this is going to be the easiest one. So let's answer the questions kind of just right over here. Okay, the critical points is where the derivative is 0 or undefined. Well, e to the 2x, this, put a little underline, this will always be positive. Okay, we know what an exponential function looks like. So that won't ever be 0, but of course what makes 4x 0? If x is 0. What makes x plus 1 0? If x is negative 1. So our critical points are 0 and negative 1. Okay, next we're going to do some sign analysis. Well, let me just do that right down here. Negative 1 and 0. And just remember, e to the 2x is always positive. If I plug in a big negative number, 4 times a negative is negative, big negative plus 1 is negative, so I have negative times positive times negative, that is positive. Okay. If I plug in a number between negative 1 and 0, maybe like negative 1/2, this will still be negative, this is always positive. Negative 1/2 plus 1 is positive, so I have negative times positive, that is negative. Okay. Now if I plug in a number bigger than 0, so a positive, I get positive, 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 so positive. So the derivative at negative 1, the derivative changes from positive to negative, meaning the function changes from increasing to decreasing. This is a max. At 0, the derivative changes from negative to positive, meaning the function changes from decreasing to increasing. So this is a minimum. Okay, so this answers number 2. I probably should have done it up here. Let me just put a little arrow. Okay. Number 3, where is it increasing or decreasing? Well, it's increasing. Let me just make a note here. When the derivative is positive. Okay, so looking at our sign analysis here, that's from negative infinity to negative 1, and from 0 to infinity. And it's decreasing when f prime is less than 0, so that is from negative 1 to 0. Now finally, I didn't give you an interval for absolute maximums and minimums. Let me do that. Let's say we're looking for the absolute maximum and minimum on the interval from negative 2 to positive 2. Okay, let's say that was the interval we looked at, and that of course would have to be given to you. So this is where we run into candidate test, where we say, okay, to figure out the absolute maxes and mins, I'm going to check the critical points and the endpoints in the original function. Okay, and again, we're looking for the max and min of the original, so that's obviously what we want to plug these values into. Now I just put this in my calculator, and I have the in a table so I can get it. F of 0 is 0. F of negative 1 is 0.271. Remember, we always go 3 decimals. F of negative 2 is 0.147. Okay. And 2, F of 2 is 436.785. Okay. So obviously the minimum is 0, and the maximum is 436.785. Now I did just graph this. Let me just pull this in so we can kind of verify. So you can see that we do have a max at -1. We have a minimum at 0, and I think, you can look, we did the interval from -2 to 2. We can't even see what's happening at 2, but it's getting very, very steep. But the minimum value from -2 to 2 is definitely 0. Let's do this one real quick. I tried to give you kind of an ugly one here to play with. This, it looks like you could use product rule, but I think it would be easiest to just multiply it in. Okay, this is x to the first. X to the 1/3 multiplied by x to the first is x to the 4/3 minus 7x to the 1/3. And now you could just use power rule, right? F prime of x, so 4/3. Now, as we are going to have to find critical points, I think it's easiest to rewrite this, kind of in a nice fractional form. So 4/3 x to the 1/3 could be written as 4x to the 1/3 over 3. And then this 7/3 x to the -2/3 could be written as 7, and then 3x to the 2/3. Now, why I think that works so nice is now I look and I say I'd like to find a common denominator. So I'm going to multiply this by x to the 2/3 on the top and bottom. Well, x to the 1/3 multiplied by x to the 2/3 is just x. So my derivative comes out to just be 4x minus 7 over 3x to the 2/3. And yeah, it's not a great looking derivative, but it'll be pretty easy to find critical points up. Okay, so first we're going to find the critical points. First let's look for what makes the top 0. 4x minus 7 equals 0. Think add 7 divided by 4. It's going to be x. X equals 7/4. Then we look at what makes the bottom 0. Well, it would just be 0. Because remember, critical points are when the derivative is 0 or undefined. Well, making the top 0 makes the derivative 0. Making the bottom 0 makes it undefined. So let's do our sign analysis here. Okay, let's put in 0 and 7/4. Now, this gives me a great chance to talk here. This being x to the 2/3. Fractional exponents, remember, this is the same as saying it's being squared, and then we're taking the cube root of our answer. Well, if something is being squared, it's always positive. So I'm just going to make kind of a little note here on the bottom that this is always positive. Okay? It's always going to be positive because x to the 2/3 means you're taking the cube root of x squared. So when you square it, it'll be positive. So let's look here at the top. If I pick a number less than 0, of course 4 times that number minus 7 is negative. Negative divided by positive is negative. Next, if I pick a number between 0 and 7/4, maybe like 1, 4 times 1 minus 7 is negative, and the bottom is positive, so this is negative. Now I pick a number bigger than 7/4. 4 times that number minus 7 is positive, and the bottom's still positive, so like that. So here, at 7/4, the derivative changes from negative to positive, so the function changes from decreasing to increasing. This is a minimum. And we say, well, what about this at 0? Well, it doesn't change. It's from negative to negative, so this is neither. Okay? And we'll see that when I pull the graph in, what's happening there. Okay. Well, increasing, well, it's increasing when the derivative is positive, so I just want to put that. That's going to be our justification. So we're talking from 7/4 to infinity. We're decreasing when f prime is less than 0. Well, that's from negative infinity to 0 and from 0 to 7/4. And you have to break it up like this because at 0, the derivative isn't negative. So the function isn't decreasing. It's decreasing and then decreasing some more, but it's not decreasing at 0, so we have to split this up. Okay. Finally, the absolute maximums and minimums. Let me give you an interval again. The interval would be from 1 to 8 is the interval I want to do. So that just means we check the endpoints and the critical points, but of course in this case f of 0 isn't even in our interval, so we're not gonna even check that one. Well, f of 1 is pretty easy to do in my head because 1 to the 1/3 is 1, 1 minus 7 is -6, so it's just -6. 8 to the 1/3 is 2, so 2 times 1, this is just 2. And 7/4, that one I'd actually have to type in my calculator, and I get negative 6.327. Okay, so my maximum value is 2, my minimum value is right there. Now let me drag my graph in here and let's just verify what has happened. Okay, kind of looks like this. Okay. Create a little room for it. Right in the middle there. So what you see is it actually right here, the derivative is undefined. It's actually a vertical tangent right there for an instant, but it's definitely not a minimum or maximum. It comes down at 7/4. Right here we hit a minimum, just as we said. We're decreasing all the way along except for 0 and increasing after that. Talking about the interval from 1 to 8, you can see that from 1 to 8 the minimum would be here, the maximum would be over here at 2.